ये हम कुछ पास्ट पेपर के क्वेश्चन जो है वो सॉल्व करने जा रहे हैं व्हाट्सएप आज ट्रांसमिशन एलिमेंट के। सारे क्वेश्चन मैं नहीं करवाऊंगा, वर्कशीट मैंने भेज दिया, आप लोग सॉल्व कर देना। कुछ मखसूस मखसूस क्वेश्चन पकड़ के बीच में से मैं आप लोगों को करवाने जा रहा हूँ। ये देखिए, सबसे पहली चीज यहाँ पे ये देखिए, ये वही क्वेश्चन जो मैंने आप लोगों को कहा था। डिस्क्राइब व्हाट वुड यू सी एंड एक्सप्लेन व्हाट हैपेंस when dilute aqueous ammonia is added to a solution containing copper plus 2 ions until the ammonia is in excess. So here you should write when a few drops of aqueous ammonia are added, the blue precipitate they are formed, and then you should write the equations I told you earlier. Because aqueous ammonia, when it is dissolved in the water, so it's a weak alkali. It produces NH4 positive ions and OH negative ions. Okay, so now what would happen? These OH negative ions, so CuH2O6 plus 2. Okay, so the two OH negative ions. So what they do, they are going to displace the two water molecules from here and copper with four water molecule and two OH. Okay, so they are going to form a precipitate which is called as the blue precipitate. So these blue precipitate are formed. So this is the blue solution. So the precipitation reaction that would occur. Okay, and when you add excess of aqueous ammonia, these blue precipitate they dissolve. So how they dissolve? I told you, copper with water 4 and OH2. So when you add excess of aqueous ammonia, what would happen? Uh, uh, the ammonia molecules, let's suppose 6 ammonia molecules. So what they do, they are going to displace the 4 water molecules from here, the 2 OH negative from here, and it is going to form copper with 6 ammonia and plus 2 charge. Okay, so this is the deep blue solution. तो इसको बस आप लोगों ने explain कर देना है. Did you get it? I told whole of this story. Yes. Okay. सर अगर अमोनिया की मॉलिक्यूल्स 4 और 7 दो वो भी ठीक है, वो भी ठीक है, ये भी ठीक है, जो वाटर भी है, पर सर अमोनिया के 4 लिख दो, वाटर के 2 लिख दो, दैट इज आल्सो ओके। और अगर तुम 6 अमोनिया लिख देते हो दैट इज, और OH अगर 2 लिख दो सर, अमोनिया 4 और 4 और 2 OH, नहीं भाई वो पॉसिबल नहीं है, दिस इज नॉट पॉसिबल। यस ओके माय डियर, now what we are going to do, uh, this is the question. Okay, sometimes they would ask you write down the catalysis. Okay, so if you see, this is the main equation. Okay, so Fe plus 3 is acting as a catalyst, or Fe plus 2 is acting as a catalyst. You can take any one of this one. Okay, so let me tell you a method how could you do it. If you see, this is iodide minus, it is going to change into I to 0. So minus 1 to 0, that is actually oxidation. This is the oxidation. Okay, and if you see S2O8, S2O8 minus 2, okay, is equal to minus 2. Oxygen valency, that is minus 2 times 8. And the sulfur one you have to calculate minus. Okay, so this is 2 times sulfur plus minus minus 16, that is equal to minus 2. So minus 16 will go on the other side to become plus 16. Okay, so 2s that is equal to plus 14. So 2 would be divided on the other side, plus 14 divided by 2. So it would be plus 7. So the oxidation state up here, that is plus 7, and up here that is plus 6. So plus 7 to plus 6, that is reduction. So reduction is going to occur. Let's suppose if these are not the equations present up here, just leave them. Okay, so if I'm going to say you that how iron 2 acts as a catalyst, iron 2, suppose iron 2. Okay, now keep remember iron 2 always change into iron 3. Okay, so iron 2 change into iron 3. So this process, that is actually the oxidation. Okay, ji? So this is the oxidation. So it means it would react with a thing which is being reduced. So this is reduced. This is reduced. So what should you do? You should write the equation up here, S2O8 minus 2. Okay. So Fe plus 2 that is going to form Fe plus 3 and plus SO4 minus 2. Okay. So because this one is oxidized, so this one that is reduced. Okay. Now this Fe plus 3 formed, it would react with the thing which is oxidized, so I minus. Okay, it would react with it to form Fe plus 2 and I2. So if you look, this thing is used up here and is regenerated up here. So this thing is acting as a catalyst. Did you get it? So what type of the catalysis is this? Here we got the ions in the reactants, and Fe plus 2 is also ion. So that is the homogeneous catalysis. Yeah, did you get it, beta? And
Yes, sir.
but did you get it? Sometimes, and Muskan is here or not?
Yes, sir.
Okay, that's fine. Did you get it, Muskan? So in the papers, he
Yes.
asked you these questions, okay? So that write down the role of Fe plus 2 in that process. So keep remember whatever the equation is given, first of all, you have to see where the oxidation, where the reduction. If he says you write down the Fe plus 3 as a catalyst, so Fe plus 3 changes into Fe plus 2. So plus 3 into plus 2, that is reduction. So you should react this Fe plus 3 with the thing which is oxidized, because reduction thing will react with the oxidized thing. Okay, did you get it?
सर होमोजेनस कैटालिसिस है ना इसमें?
जी जी, होमोजेनियस कैटालिसिस है भाई साहब। सर अगर हेट्रो होता तो भाई ये चीजें आयंस हैं, तो वो चीज जो है वो किसी और फॉर्म में होती, लिक्विड फॉर्म, आई मीन सॉलिड फॉर्म में होती, शुड बी गैसियस फॉर्म, एनीथिंग एल्स। ओके, okay, these are the same definitions up here. So here he is asking that which species could act as a ligand. NO3 minus, if you see, this is the negative ion, so it can act as a ligand. BF3, BF3, it does not act as a ligand क्योंकि बोरोन के पास तो पहले ही इलेक्ट्रॉन कम है। ठीक है जी, ये NH2 में नाइट्रोजन got the lone pair, so it can act as, oh sorry, it can act as a ligand. NH4 positive, the lone pair of the nitrogen has used in the making the dative bond with the H positive ion, so this could not act as a catalyst. Okay, I mean ligand. Okay, guys, see these kinds of the question. ये ध्यान से सुनिएगा जरा. If you look up here, Mn plus 2 aqueous, so this Mn plus 2 aqueous mean Mn with water molecules like that and plus 2 charge. This means that. Okay, so if you add the sodium hydroxide in it, so it will produce the OH minus ion. Okay, so OH minus ion will form the precipitate of this one. So you would have Mn water 4 OH2 and this is neutral. Okay, and this is the precipitation reaction. Did you get it? Okay, guys, if you look up here, Mn plus 2 and concentrated HCl. So this one produces the chloride ions. Okay, so what would happen? MnCl4 negative 2. Okay, so this is the ligand exchange. Okay, and this is Mn plus 2. Mn plus 2, and this H2O2, keep remember it's an oxidizing agent. And sodium thiosulfate S2O8 minus 2, so that is also the oxidizing agent. So both of these things, they are the oxidizing agents. They oxidize the thing. So Mn plus 2, इससे ज्यादा ऑक्सीडेशन स्टेट वाली कोई भी आप Mn की चीज लिख दो, MnO4 माइनस लिख दो, इसमें Mn की ऑक्सीडेशन स्टेट +7 होती है, तो +2 से +7, दैट इज एक्चुअली द ऑक्सीडेशन. ठीक है जी, सो दिस इज द रिडॉक्स रिएक्शन. डिड यू गेट इट? अगर इस तरह नहीं लिखना तो आप लोग इस तरह लिख सकते हो, Mn वाटर के 6 molecules and it got +4 charge. ओके, तो +2 से +4 लिख दो. लेकिन आपको इस चीज का तो पता है ना, MnO4 माइनस, तो ये लिख दो, ये ज्यादा बेटर है. ओके, क्योंकि इन MnO4 माइनस Mn हैज द +7 ऑक्सीडेशन स्टेट. सो दीज आर द सेम क्वेश्चंस. ये देखें वही, ये निकल वाला जो मैंने आपको कहा था कि आप लोग याद कर लीजिएगा, ये देखिए ये वही है. व्हेन अमोनिया इज एडेड to a green solution containing nickel plus 2 aqueous ion, a gray green precipitate is formed. This precipitate dissolves in excess of aqueous ammonia to give a blue violet solution. तो ये देखिए इसमें लिखा हुआ है तो इसमें वो आपने इक्वेशंस वगैरह सारी बना. Okay, so first of all, ammonia, it dissolves in water to form NH4 positive and OH negative thing, and nickel with 6 water ligands and +2 charge. So the two OH negative would join with it to form nickel H2O4 and OH twice. And this is, my dear students, neutral. Okay, the two water molecules, they will come out. So this is the precipitation reaction. So this is, he said gray green precipitate. So gray green precipitate. So you should write all these things up here. Did you get it?
Yes, sir.
Okay, so whenever you want to draw the electronic configuration of any transition metal ion, so most of the students, what the mistake they do, they just write up here the chromium has got the proton number 24, so the electrons up here they would become 21. So what they do when they fill the electron, so 2p6, 3s2, 3p6, okay, and then 4s2 and 3d1. So they wrote like that, which is 100% wrong. Okay, why? Because there, whenever there is the ion, you shouldn't do it like that. Don't make the electron appear 24. So just make the total 24 electron, 1s2, 2s2, 2p6, 3s2, 3p6, and then you got 4s2, and then you got 3d. Uh, this is 4s1, sorry, 4s1 and 3d5, because I told you chromium has the unusual electronic configuration. Now plus 3 charge means now you have to remove the electron first of all from the valence shell. Valence shell is 4s. तो पहले यहां से इलेक्ट्रॉन निकालने और फिर 3 निकालने, यहाँ से 1 निकला अभी तक, तो बाकी 2 यहाँ से निकालने, तो यहाँ पे 3 इलेक्ट्रॉन बच गए. So this one would be the electronic configuration. So whenever you want to make the ion electronic configuration, first of all make the total electrons and then remove the valence shell electrons. Okay, did you get it? Have a look up here, whatever the d orbitals we have discussed up here. He's asking on the following diagram, draw a clear label diagram to describe the shape and symmetry of the typical d block element. So this is the y-axis. First of all, you should draw x, y, and z. Okay, so you should draw up here. This is on x-axis and this is on y-axis. So this is called as the dx square minus y square. Okay. Okay. Now he's gonna say you, although the 5d orbitals at the same energy level in an isolated atom, when a transition element ion is in an octahedral complex, the orbitals are split up into two groups. Draw a orbital energy diagram to show this, indicating the number of orbitals in each. So in octahedral complex, I told you the ligand provides its electron through the axis. So the two d orbitals which are present on the axis, they shift at high energy level, whereas the three, they would remain at low energy level like that. Use your diagram as an aid in explaining the following. Transition metal ions are often colored. So I told you the whole reason. Okay. When the transition metal ion form the complex, okay, the ligand provides its electron either through the axis or in between the axis, due to which the d subshell splits up into two sets. In case of octahedral complex, the two d orbitals are at high and three they are at low energy level, and visible light is able to cause GD transition, due to which different due to absorbance of visible light, different colored complexes they are formed. Okay, did you get it? Okay, guys, any one of you could tell me, calculate the oxidation number of carbon in this ion. Oxidation number mean oxidation state of carbon. So you got 2 carbon, C2, you got 4 oxygen and -2 charge. -1 up here, -1 up here. So you want to find out the oxidation state of carbon. So is equal to, this is minus 2, right? Minus 2 up here. The valency of oxygen, that is minus 2 times 4, and then 2 times carbon. So it would become 2C minus,
Sir, three answer.
जी सर 3 है, is equal to minus 2, 2C is equal to minus 2 plus 8. So 2C, that is equal to plus 6. So 2 would be divided on that side. So it would become plus 3. So the oxidation number of this one is plus 3. The next thing, calculate the oxidation number of iron in this one. So iron का आपने बताना है. So iron X plus C2O4 has got the charge negative 2. So negative 2 times how much are present? 3. 3 are present. So times 3 is equal to minus 3. Minus 3. Okay, so X minus 6 is equal to minus 3. Minus 6 will go on the other side to become plus 6. So it would become plus 3. So its oxidation state is plus 3 as well. Did you get it? Yes. Okay, guys. Any one of you could tell me what type of the reactions are these? First reaction, water is displaced by the ammonia. So this is the ligand exchange. Okay, so it would be the ligand exchange. Ligand exchange. If you see Cu, and this one is also the ligand exchange. This one, if you see F is plus 2 up here, it is plus 3. So this is the redox reaction. Redox reaction. So if you see this whole thing is neutral, so it would be a precipitation reaction. Precipitation. Yes. Whenever OH they are joined. So if you look up here, this is plus 2 and here it is plus 3. So this is the redox reaction. So this is the metal oxide, they are basic, and this is the acid. Metal oxide and acid, they would react to form the neutralization reaction. So this is the acid base reaction. Okay. And then if you look up here, the OH minus they would join. So this one is negative ion. So this is soluble. Now this is the ligand exchange reaction. Ligand exchange, whatever it is. Okay. So these type of the reaction he could ask you. आखिरी वाला देख लो यार, उसकी ऑक्सीडेशन स्टेट चेंज हो रही है. Redox reaction. Okay, guys, he wants you to draw the two complexes up here. Okay, तो इसको जो है वो आप लोग ड्रॉ करने हैं. कॉपर, this is the octahedral complex because 6 ligands mean octahedral. Octahedral में डायग्राम इस तरह बनाते हैं, दो लाइनें इस तरह. This is the triangle like that, and we should write the water up here. OH2, OH2, O को ज्वाइन करना होता है. OH2, OH2 and OH2. Okay, so this is having the plus 2 charge, so make it as plus 2. Okay, guys.
Yes, sir.
Okay, guys, यहाँ पे वो structures बनाने के लिए कह रहा है. ये देखें, if you look up here, he wants you. This is the structure. This is the complex. इसके वो कह रहा है कि जी isomers बनाएं. So you should draw it like that. This one contains 2 and 2, 4. So 4 ligands are present. So you should draw it like that. This is the square planar.
सर ये मोनोडेंटेट है या बायोडेंटेट?
और भाई अमोनिया मोनोडेंटेट ही होता है. बायोडेंटेट व्हाट्सएप कहां से आ गया? So ammonia, this is chlorine, this is chlorine. So this is my dear cis, and what is its trans? The trans would be like that. Okay, this is ammonia, and this is ammonia, and this is chlorine, and this is chlorine. So this is the trans. So you want to show the नहीं, इसमें इसमें नहीं जरूरी. वो अगर तुम एरो बनाओगे तो तब लोन पेयर शो करवानी इसमें. Okay, guys, did you get it? So
Yes,
now
sir.
what I want you people, that I have sent you the worksheet. So you should practice this whole worksheet at your home, and whatever the problems you got, okay, you should discuss it to me tomorrow.